Hello friends, welcome to my channel. Let's have a look at problem 297, serialize and deserialize binary tree. This problem or this video is a follow-up for problem 652. So here we practice both serialization and deserialization. So in between we're going to use recursion here for simplicity or neatness. So this problem asks us to do serialization or deserialization of binary tree. So here are two examples. For example, this example 1. So you can this is the tree structure, and example 2 is an edge case which corresponds to a null tree. The constraints for this problem are the following. First, the number of nodes in the tree is in the range given by the closed interval 0 to 10 to the power 4. And the node value is in between -1000 and +1000. So with that said, let's look at the code. So here we are given a class called Codex. So this class, the problem asks us to fill up two methods. One is serialize and the other is the reverse, the deserialize. So here, unlike problem 652, we need to also take deserialization into consideration when we do serialization. So this actually is slightly more demanding comparing with problem 652. So here, first we're going to do serialization with the help of traversal. So here we can use depth first search as in problem 652. So for the first method, we're going to do the similar thing as in problem 652. First, I'm going to initialize a result variable, which is an empty list. So we are going to write a DFS function or a worker to modify this one. And then later we do string join on this result list to get the representation of the whole tree. So with that overall structure done, now let's first look at the hyperfunction. So here I'm going to use DFS again, so which accepts a tree node. Let's use root and an argument name. And then first, if not root. In other words, so we are meeting a null tree. So in this case, so we can append the result with some special string, let's say null or none. So let's use a comma. So this comma is used to distinguish digits. So you'll notice that soon. So here let's return if this is the case. So otherwise, so we're going to first add this string representation of the node value to the result. So this is string. Let's add root value. And then let's also add a comma here, so to distinguish digits. And then we do the depth first search in the left subtree and the right subtree recursively. So let's call this function DFS root left and DFS root right. So this way, after we finish this recursion, we're going to get a result a list which can be regarded as a representation but in a list format. So then we just need to do string join method. So as we have already initialized the result variable, so we don't need to do it here. Now we just call this function, right? DFS root. So after that, so actually we can return the full string. So we are going using string join method. So here the separator is empty string or empty thing. So here we get the result. So this is what we return. So actually here we can add something. We can print out the result or this joined string. So this is the serialization. So with this serialization method, we can write a deserialization function. Let's do this here. So here we are going to first define a hyperfunction which is going to do the split and to build the tree. So here, and then we are going to call this function, and then we are going to finally return this result. So first, I'm going to define a hyperfunction. So this is the builder, right? So first, let's do this one. If q not, so is so here q, you can think of q as the list here before the joining, right? So if q not is null, so then we are going to do pop left, and then we are going to return. So the reason here we use this null because once we split the data into this kind of format, where the separator for the split will be the comma, right? So we just have null with no comma. So that's the one step. Otherwise, the first one, q naught, will be a number, so corresponding to a number. Let's see. What we are going to do is we're going to write the root will be a tree node. So the value will be pop left. So this one, or you can regard it as a string. So it should be still okay. And then what we are going to do next is to call this hyperfunction recursively, actually following the here similar way. So L will be hyper Q. So because here we are using pop, actually the state of the this Q changed, right? Yes, hyper Q. And then we're going to set the root of left to be left, and root right to be right. And then we're going to return the tree. So this is the hyperfunction, so which accepts a list of strings. So with this function ready, so now what we are going to do, first we get the list, right? So we are going to, let's write like this, so list, so we're going to get split. So here, as we used a comma as separator, so here in the separator we're going to write a comma again. And then we're going to, in order to use pop left or pop right, or pop from the right, so let's first build collections deck. So we can make a deck out of this list, and then we're going to, similarly we can print the queue. And then what we are going to do is to return the hyper queue. So this is our way of doing the deserialization. So let's first do a check. It passes one example. Now let's look at the generic case. It passes all the generic cases. So here, one thing I guess it might be interesting is that we can change this one to be int. So if we like, let's test again. Yeah. So it also passes. So because here we are actually use some type conversion, like here string. So here we can write int. So meanwhile, so we can do the print. So here you will see the serialization and deserialization procedure more clearly. So let's see. This is the tree corresponding to this here, 1, 2, 3, 4, 5. So we're going to get something like this. So this is the list before join. So if we join, we are going to have a string, long string like this. And then when we input this string format of this list into the deserialization function or method. So after we do this step, we do split. So we're going to get something like this, right? So here, if we do not put integer here, the value will be in a string format. But in a proper sense, maybe it's better to change it to be integer. But it's not a big problem here because this is not very strong in type. So with that said, I guess that's about it for this specific problem. So here the thing is that, so when we do serialization, we need to keep in mind the deserialization. So because the deserialization method depends on how we do serialization. So here in both the two methods, so we used recursion. So this actually is very neat, or in some sense we actually do some cheating, maybe it's to hide which actually hides some details. But if you prefer, I will encourage you to write the two methods in the iterative format. So for this one, it's not hard at all. So similarly, with some effort, writing a recursive format for this one is not easy if we are very familiar with binary tree traversals. So with that said, I guess that's about it for this specific problem and this video. Thank you.